In this video, I want to focus on the mathematical concepts of rounding and estimation, which is very important for students and academic students and critical thinkers in general. So let's jump straight into the video. We will focus on the topics of rounding, estimation and bounds. So before going into each topic, I want to focus on one topic at a time. So let's go to Google, and if I've already done this, so I have just typed what is rounding in mathematics. So if I go to this question that people also ask, which is what is rounding in math examples. So rounding means making a number simpler but keeping its value close to what it was. So the result is less accurate but easier to use. So example, 73 can be rounded to the nearest 10 as 70, because 73 is closer to 70 than to 80, but 76 is closer to 80, so 76 goes up to 80. So if rounding, if the numbers 73 and 76 is rounded to the nearest 10, 73 is closer to 70 and 76 is closer to 80. So let's apply this concept mathematically. So I have used this Save My Exams platform, and I am going to focus on medium category problems. There are 4 categories here: easy, medium, hard, very hard. I will only focus on the medium categories, and let's look at the first problem, which has 2 parts, 1A and 1B. So if I focus on the first part, it says the value of P is 4.3 and the value of Q is 0.4. So both P and Q are given correct to the nearest 0.1. So what does correct to the nearest 0.1 mean? So if I use my notepad, if I use my pen tool, let's say this is the pen tool. So P is denoted as what? The value of P is 4.3. So what is 4.3 rounded to the nearest 0.1? So if it's rounded to the nearest 0.1, we can write 4.3 as what? 4.30, right? This is the same. 4.3 and 4.30 is exactly the same. So if 4.30 is rounded to the nearest 0.1, it means what? Any number between 4.25 to 4.35 can be rounded as the nearest to 4.30. For example, 0.28. This is near to 4.30. Right. So again, another number, let's say 4.32 is close to 4.30 in terms of nearest 0.1, right? So any number between this range 4.35 or 4.25 and 4.35, between 4.25 and 4.35 is close to 4.30 and therefore can be rounded to 4.30. So what is the lower bound for P? So what is the lower bound for P? So if 4.25, this is the lower bound of P, and 4.35, this is the upper bound in terms of value, right? So 4.25 is the lower bound and 4.35 is the upper bound. And if I now focus on problem 1B, it says that R is equal to P plus 1 by Q. So let's write this equation. Let's say R is equal to P plus 1 by Q. So R is P is equal to 1 by Q, and we know the value of P and Q is given. So let's use these values, which is what? 4.3 plus 1 by, what's the value of q, which is 0.4. So this is 0.4. So what is the value of 4.3 plus 0.4? I can use the calculator just to quickly do it. 1 divided by 0.4, this is plus 4.3. This is 11.1. Okay, so the value is 11.1. So this is the result. So what is the nearest 0.1 to 11.1? Now this can be written, this one is, you must show you're working, write out the upper bound for r. So this is r, right? So this can be written as what? 11.10. So what is the lower bound for 11.10? 11.05, and the upper bound is what? 11.15. This is the range for which any number can be rounded to 11.10. So this is the answer, which is 11.15, the upper bound. So problem number 2 shows there is an equation given. I equals to 5 multiplied by v minus u. So here the variable v is what? 14 correct to 2 significant figures. I'll explain this. And u also says 8.7 correct to 2 significant figures. So let's use my notepad. Let's say use my pen tool. So what is given? V is 14 correct to 2 significant figures. So let's use the equation first. A variable I is equal to what? 5 multiplied by v minus u. Okay, so it's 5 multiplied by v minus u. So v, the variable v, the value of variable v is given as what? 14 correct to 2 significant figures. So 14, so this 14 correct to 2 significant figures, what does this mean? So 2 significant figures means there are 2 figures here, 1 and 4. So 14 correct to 2 significant figures is actually just 14, nothing else. So similarly, u is 8.7. You can also write 14 as 14.00. There is no problem with that. So if I write u as what? The value of u is given as 8.7. So the value of variable u is given as 8.7, and also this is correct to 2 significant figures. So what are the 2 significant figures? 8 and 7. So 8.7 is also the same. When it said it is correct to 2 significant figures, you can also write it as 8.70. There is no problem with that. As long as 2 significant figures is correct, there is no problem with that. So work out the upper bound of the value of I. So let's figure what is the value of I. So what is the value of I? I is what? 5 multiplied by v minus u. So if I use the value of v and u, which is, let's use 14 minus 8.7 for simplicity. So this is what? 5 multiplied by 5.3. Right, 14 minus 8.7 is 5.3. So what is 5 multiplied by 5.3? It is, let's use the calculator. Let's say 5 multiplied by 5.3. So this is 26.5. So this is 26.5. Now we can write it just as 26.5, or we can also write it as 26.50. Okay, so you have to find the upper bound of the value of I. So what is the upper bound of 26.50? 26.50 can be given as a range, which is 26.45 to 26.55. So any value within this range will be closest to 26.50. For example, 26.47. This is closer to 26.50. Similarly, 26.54, this is also near to 26.50. So the upper bound, because there is no specific requirement, you can write, you can say the upper bound of I is what? 26.55. This is the upper bound and this is the lower bound. So this is the lower bound and this is the upper bound. So 3 and 4 are very similar. So in 3 and 4, in both cases, you have an equation and you have to solve the equation and then find either the upper bound or the lower bound. In both cases, it says it requires the upper bound. So this is very similar to 2 where the equation was given. So I'm not focusing on 3 and 4. So I'll jump into 5. Okay. So before going into 5, I have to briefly look into the concept of estimation. So what is estimation? If I go to Google and search what is estimation in mathematics, it says, like a brief overview is, in short, estimation means having a rough calculation of number, value or quantity. So estimation is basically a rough calculation that is close to the number. It doesn't require you to have a very precise calculation. Okay, the best way to estimate is to round up the numbers to the nearest 10, 100 or 1000. This enables you to perform mathematical calculations easily and speedily. So estimation enables you to perform calculations very quickly. So this is one of the core purposes of estimation. So you have to first understand the subtle differences between rounding and estimation. So if I go to my note, let's say 2.467, this number. Now it has 4 digits, right? 2.467, 1, 2, 3, 4, 4 digits. So what is the difference between rounding and estimation? In rounding, I want to lessen the number of digits. So instead of 2.467, I can write what? 2.5, right? This is one of the purpose of rounding, is to lessen the number of digits while also keeping it close, very close to the actual number. So 2.467 can be written as 2.5 because which is close to 5, right? So one of the core purpose of rounding is to lessen the number of digits while also keeping the calculation precise. But in terms of estimation, you don't necessarily require that. So for example, 53 can be estimated as 50 even though the calculation is not that precise. Similarly, 47 can also be estimated as an approximation to 50 even though 47 to 50 is not that precise. So when I add this, I can also add this as 50 plus 50 instead of adding 53 and 47. So in both cases, I get what? 100. So this is how I can quickly make estimations. For example, if I want to add 53 and 47, I have to take some time to actually have the calculation. So, but if I estimate to both of them to 50, I can easily calculate it much quicker and faster. So this is one of the core purposes of estimation. So these are some of the subtle differences of rounding and estimation. So now if I focus on the problem number 5, which says there are 892 liters of oil in Mr. Aston's oil tank. He uses 18.7 liters of oil each day. So you have to estimate the number of days it will take him to use all the oil in the tank. So how much oil is given? 892 liters, that's the total, and each day 18.7 liters of oil is used. So if I write it, let's say 892 liters. Okay, so this is very simple, which is the resultant is what, 892 liters is the total, and 18.7 liters is used each day. So now I have to find the estimation. So if I just do a basic calculation, let's say I use a calculator and use 892 divided by 18.7. So the resultant is 47.700. Okay, so this is what, 47, this is a big number, let's say 47.700. I can avoid the rest. I can just write 47.700. okay, because I am estimating, and it's best to estimate in the nearest 10 or hundreds or thousands, etc. So it's best to estimate, even though the answer is very close to 47 and 48, it's best to estimate the number as what, it is close to 50. So the estimation should be like, it will take 50 days approximately to fill all the oil in the tank. I hope you have some idea about the concepts of rounding and estimation that I covered in this video. In the next video, I'll focus on some more practical or mathematical problems regarding these concepts, rounding, estimation, and also focus on another concept, which is bounds. So till then, stay tuned.